scanning electron microscope for the examination of particle morphology and surface texture and a study of microencapsulation pesticide formulation. X-ray, both single crystal XRD and powder XRD play important role in the characterization and determination of crystalline structure of the solid pesticide and identification of polymorphs. CHN analysis also play important role in the characterization of pesticide to confirm the empirical formula by measuring the percentage of carbon, hydrogen, nitrogen and sulfur, and photoelectron spectroscopy determine the oxidation state and bonding environment of the surface area. And then combined technology like LC-MS-MS and GC-MS-MS is also very important to sensitivity method for the trace analysis in environmental monitoring. And nowadays molecular docking and enzyme assay process like cholinesterase inhibitor test for the organophosphate toxicity and molecular docking like enzyme interactions. So these are the comparisons. So why fluorescence is very play important role in the detections of pesticide. You know, the fluorescence spectroscopy is a highly sensitive and selective technique based on the ability of certain molecule to absorb light at one wavelength. You can see this is the PET and weaker excimers formation like the pyridine. So principle of fluorescence, we know that the excitations and emissions you should know, and this is the diagram showing the how molecule excite and then it come to the losing of electron energy, then it gives the fluorescence. This is the basic techniques. We know the types of fluorescence like steady state fluorescence spectroscopy and time dissolved fluorescence and quenching. Quenching occurs when the fluorescence of a pesticide is reduced due to interaction with the another molecules. Dynamic and static, both type of quenching. We have the application investigation of pesticide binding with the serum albumins or enzyme, understanding the molecular recognition in biosensor. So quenching of tryptophan fluorescence in the bovine serum albumins upon binding with the chlorpyrifos. So these are the another confocal laser scanning microscope and 2-photon fluorescence spectroscopy also using imaging for the fluorescently labeled neonicotinoid pesticide inside the leaf tissue. So fluorine based sensing play important roles in the detections of the pesticide. So I am going to show you, this is the difference between the advantages of fluorescence technique in pesticide analysis. So based here is the non-fluorescence pesticide requires derivatives and fluorescence quenching by the environmental matrices can affect the accuracy, and photobleaching and pH dependence may alter the signal intensity. So I have developed one pyridine derived porous organic polymers because it pokes as a fluorescence. So these POPs are used to detect organic pesticides such as trifluoralin and dichlorine. The detection mechanism involves fluorescence quenching. The pesticide, which has electron withdrawing groups, interact with the polymers and quench its fluorescence, LNU 45, and especially high sensitivity. You can see in this figure. So I have focused on trifluoralin and this dichloride. So the basic chemistry here, if you are interested, then you see the both pesticide have different environmental nodes here. It is relatively persistent in soil, low in water solubility, and volatile. Care should be taken to prevent runoff and groundwater contamination. So there is a comparison between these two pesticides. So analytical technique, characterization technique we are using for this only the fluorescence, and why fluorescence is important. Here you can see I have designed one new molecules on the basis of pyridine. This is the monomer, this is the another monomer, this is the formation of LNU, and this is the another monomers, this is the monomers, and this is LNU 47. So after X-ray crystallography and NMR, IR, we got this crystals. This is the transmutation versus wavelength. This is IR, and how the fluorescence is playing. You can see the A, this color after UV light, this become this, and you can see the quenching of the fluorescence. Here UV lamp, you can see the quenching of MtEl, TCM, DCM, different solvent. And this is the, the pyridine forming the excimer formations. That's why it is environmentally friendly, environmentally very sensitive molecules. This is another characterization technique like fluorescence intensity versus wavelength. So, my friends, I have discussed here to conclude, we can say that pyridine-based fluorescence sensor provide a powerful platform for pesticide detection due to their high sensitive tunable emissions behavior and easy to chemical modification. So I would like to thank to the organizers for giving me this opportunity to share my work and thought on this fascinating topic. My friend, my sincere thanks to the audience for their attentive interest throughout the sessions. I welcome any questions or discussion. Thank you again for your kind attention.
Thank you. Thank you very much, Dr. Muhammad Sirajul Haq Faizi. It was an